Okay, good afternoon, people. So this is the beginning of week 6, lecture 1 of week 6. We started the subject of hybrid analysis on Friday. So we did one problem. Today I'm going to do a second problem, and tomorrow in your lecture we're going to wrap it up, okay, and then we move on. Now this week your homework deals with this subject, okay. Already solutions were posted, so if you watched my lecture on Friday and you did a little bit of work of watching these things on the video on YouTube, you could have done your homework for which is due 24 hours from today, okay? Now, here's a problem that I have. As soon as you see this, you should understand that this problem has to be done with 3 types of elements, all in the same model. This cylindrical thingy in the middle, it has to be meshed with solid elements. This thing, and I try to draw it kind of a thin, structure compared to that, with shell elements, and these slender things as beam elements. Must be like that, otherwise you're not going to like it. Now, the dimensions are given here, and then you're told that these ends are clamped, the ends of this clamp, and if you hear that these parts are perfectly welded or perfectly glued or perfectly bonded together, it means that at these joints, wherever possible, you have to use fasten. And wherever fasten is not possible, such as the corner of a plate and a end of a rod, it has to be rigid. Okay? Now, you're supposed to use all planes of symmetry, and in this problem, the loading is raising the entire thing by 500 degrees. That means as if you took this thing and put it in an oven and yanked it up to 500 degrees Fahrenheit. You're supposed to know how is this going to deflect and what are the stresses, etc., etc. Use all planes of symmetry. Can somebody tell me, based on what I just said, how many planes of symmetry you have and what they are? Okay? Can I find a good guy or gal to tell me what it is? Just speak up.
I think you have 2 of them. You have the ZY and XY planes.
The 2 is correct. Did you say ZY and what?
XY. Sorry, XZ, my bad.
X, that's a lot better. Now, of course, if you tried XY, you would have quickly realized there's something wrong here. But don't make that mistake, please, because if you identify the planes of symmetry incorrectly, you lose, whatever percentage marks you've got for that particular problem. I mean, obviously, the rest of it, if you do okay, you're okay. But don't make mistakes on identifying number of planes of symmetry, because that causes a problem. Okay, you're right. Now, you have 2 choices. By the way, just remind you that the number of planes of symmetry and the nature of it depends on not only the shape, but also the restraints and also the load. For example, if one of these was not clamped, forget it. There are no planes of symmetry. If C and A were free, there are no planes of symmetry. Okay, so don't let the figure fool you. You have to look at the restraint and you have to look at the load. Okay, good. Now, in the videos that I've prepared for you for the solution of this homework this week, I said that there's 2 ways to do these problems. One is to make it all within a single part, and I'm going to do that for you, and I did it on the videos. And you can also do it as an assembly of 3 parts, okay? The 3 parts, the way I did it, was the solid part, the shell part, and the lines, basically, okay? It's up to you. It seems to me that doing it as a single part is maybe fewer steps than doing it as an assembly. The other thing is that when it comes to modeling this, you know, you just told me that there are two planes of symmetry. You have a choice of making this whole thing and then start basically stripping away everything that you don't want. That's one way. Or you can make 1/4 of this to begin with. And this is what I'm going to do. Okay, I'm going to make 1/4 of this. Okay, so let's start. Let me get my dimensions all sorted out on the other computer so that I don't have to go back and forth between this. Okay, so we go here. We're going to start with a part file. First, I'm going to do it as a single part, and I'm going to come and do it as an assembly because it's good for you people who may not get a hybrid, who may get an assembly problem. Then at least you have seen the motion for the assembly, okay? All right, let's save this thing right away. File, save management, save as, desktop, new folder, and I'm going to call it, this is lab 53, and I'm going to say single part. Okay, very good. Put everything in there. All right. You have to decide where you want to go start. In other words, do you want to start at making the solid part or the surfaces? It really doesn't matter. Since I am in a generative shape design, why don't we draw our surface first, and then the line, and then we go to part design and do our solid part, solid in that cylinder. So on that plane, I will sketch. Now my dimensions, that plate is 8 inches by 4 inches wide because I'm doing 1/4 of that, so I'll do 4 and 2. Instead of 8 and 4, I do 4 and 2. So this is going to be 4, oops, 4. And this one is going to be 2. Okay. And exit. And as long as you have a closed here, you can always FILL it, fill it. Now, you could have also drawn a line and extruded it. It really doesn't matter. It's up to you how you want to make that surface. Now, I need one of these bars sticking out, just them, because this is 1/4 of the model. So here I'm going to make a point. Now it's up to you how you want to draw that line. So let's do the line.
Professor,
point.
Can I ask a question?
Yes.
So you're using here now at the moment generative shape design?
Yes.
What is the difference between a generative shape design and wireframe and surface design?
You can do it there too. Wireframe and surface design is the stripped down version of generative shape design. For us, it makes no difference. We make simple problems. But if somebody is making an instrument panel and things like that, there are things that you can do here that you cannot do in wireframe and surface design. For us, it doesn't matter. Yeah.
And what you did here is instead of drawing a line and extruding it, you just drew like a full rectangle and filled it from the surfaces bar. Okay, yes. Got it. Thank you.
Entirely up to you. Okay, so let's do a line, point and direction. This is the point. Direction is Y in this case. And the length is, I think, 1 inch. The length of those bars is 1 inch. I think you have to put 1 inch. There we are. Okay. Now, we're going to make our cylinder, 1/4 of a cylinder here. Since it's going to be eventually, we have to pad it, we're going to go there. Okay. And we're going to go to part design. Okay. And on this XY plane, I will sketch a 1/4 of a circle. That dimension of that, the radius of that circle is 1, so might as well give a dimension here. And we have to close this because in order to pad, you need to have a closed shape. There we are. Okay. Good. Exit. Pad it by a height of 2 inches. Okay. Now, everything is made out of steel. So let's go ahead and put apply material, metal, steel on the part and say OK. All right. Now I want to, well, let me go ahead and mesh it, and then I say a few words about what we have done. Okay. So we're done here. So we're going to go to, did I save this? I think, yeah, I did save. Okay, let's save it. Okay. Listen, guys, I'm going to say this thing for the next 2 weeks, repeat it. You have 2.5 hours. Yes, yes.
I'm just curious, like when you drew that beam element, is it in the right place? I thought it's supposed to be in, on the opposite point along the
Okay,
surface.
well, oh, you're absolutely right. Oh my God. Oh, you're right. Whoa, thank you.
Yeah, no problem.
Yeah. Okay, so where is this line? So let me double click on it. Instead of the point, let me see if I can save one step and doing it like that. Ah, you're absolutely right. Don't make mistakes like this. You don't want it.
What is that? What is that line again?
This line,
Mm-hmm.
that is one of these beams. See that? One of these beams sticking out, right there. I'm doing this piece.
Yeah.
Okay.
This was arrows. Oh, got it.
Yeah, it's one of these beams. Now, as I said, I'm going to say this thing for the next 2 weeks for you before you write your test. You know, you have 2.5 hours for 3 problems. And you know what the 3 problems are. There are no surprises. There are solids, beams, shells, hybrid, and assembly. And when I say assembly, I mean assembly of solid objects, like, you know, the pen, you stick the pen into that hole and do that kind of a thing. Of course, you have a choice of making these with assemblies too, but that is not the assembly that I'm talking about. So when you do a problem and you're done and you're happy and you no longer want to think about it or work on it, well, save it. Now, when I say save it, is first of all, save it on your secure drive. Secure drive means in the event that you lose power, in the event that you're booted out, okay, of the system for whatever reason, then at least you can get that. So that could be your USB, it can be your, if you're doing it in your computer, your C drive. Now, I don't know how it works at the university. If you use the university's version, the OneDrive, it used to be Z drive. I don't think they call it Z drive anymore. Anyway, and submit it to Blackboard. Drop it in the right place. Do not wait until the very end when your time is up. And suddenly now you have to put these things and put them in the right spot in the Blackboard, etc. Because the plan is, if now I haven't finalized this yet, I have to discuss it with the GAs too, and we find out every 5 minutes that you submit it late, okay, we're going to deduct marks. Okay, so that's hypothetically, this is not sorted out. First 5 minutes late, 2 marks lost. Next 5 minutes late, another 2 marks. 15 minutes, another 2 marks. And after the point, you're not going to take any of them. So please save these when you're done. Okay? All right, good. Now, we also give you a certain number of attempts that you can save, okay? But anyway, these details are going to come in later. Okay, so now we're going to go to generative structure analysis. Immediately, CATIA sees a 3-dimensional object, and it has a habit of meshing it, and it did. That solid cylinder is meshed. Now, we have to do the rest, okay? So obviously, this is going to be meshed with shell elements. this thing out of the way. Shell element. There we are. And let me make it a little bit smaller, 0.2, 0.3, whatever. Unless we tell you to do parabolic, you can use linear. Now, sometimes, remember, I did have a situation where linear did not work. Either I had to change the size of it or made it parabolic. We don't care. We just want to make sure you don't accidentally use parabolic and you put a micron here and it's going to take forever to run and then you have to kill the job and you didn't save it and stuff like that. Okay, good. Thickness. Thickness of this is a 0.02. What is that? At least in the problem description that I gave you is 0.1. 0.1 right here. See that? What is this thing? Yeah, thickness of 0.1. Okay. And we say, okay. Now, I want to tell you something that you might say, well, wait a minute. If that is not quite correct, why are we doing it? You see, later on, I'm going to make a connection between the face of this, right? The face of this, I mean, this surface, and the bottom of that, right? I'm going to make a connection like that. And for example, if parts are fully bonded or fully welded or fully, I can't remember the other name that I used. Glued, fully glued, means that it's a fastened connection. But think about it. The bottom of that cylinder is not really on top of that plate. It is fastened with the middle section of that plate. So we are shortchanging this a little bit. I understand that. And for us, it doesn't matter. But when you're designing hoods and door panels and instrument panels, these differences make a difference as far as the tolerances goes. For us, we ignore the fact that, there is some kind of a vagueness here because we're saying that the bottom of this is actually glued to the middle surface of that plate, not to the top of the plate. Because ordinarily, you take this thing and put it on the top of the plate. Top of the plate means top surface of the plate. But the way we are doing it, we are as if we had access to the middle surface of the plate. So that really is not too, Is not 2 inches high. It is 2 inches minus half the thickness of that. Half the thickness of that is 0.05. So this is really the one that we're modeling is actually not 2, it's 1.995 or something like that. Don't worry about it. Okay? Good. Let's mesh this guy. Beam. Right there. This whole thing was 1 inch, so I put 0.25. I don't want to use just 1 inch, just one element, although it's perfectly okay. And the type of thickness, type of property on this, it's circular, cylindrical. The section radius is, let me see what it is, 0.02. 0.02. So if you say 0.05 here, because I don't know, the other problem that I did was 0.05. 0.02. Be careful with these numbers because it remembers something that you don't mean really. That's it. Because it's circular, you don't have to worry about orientation point, etc., etc. Okay, let's save our analysis. File, save management, analysis, save as. That same folder, which I call Lab 53 CL part, default. Now you know at the end that you have to change these so that it starts with the student ID number and your last name, and then move on. Problem, whatever. Problem 1, problem 2, whatever. You know how to do that very efficiently. Good. Okay. Now let's apply our restraints. So this end is clamped. Where's the clamp guy? Right there. It's a microscopic clamp. If you zoom in, you can see that. Okay. And honestly, I don't know why sometimes it puts it big, sometimes it puts it small. I'm not sure on what basis that is decided. Now, we have surface slider here and there. So where's the surface slider? There it is. There. and there. Now remember, all the surface slider does, it says that there is no displacement perpendicular. So instead of surface slider, if you don't want, say, displacement in direction y is 0, displacement in direction x is 0. But I mean, surface slider is easier to use. Now these guys, I cannot use surface slider. Okay, these are edges of a shell. You cannot use surface. If you put a surface slider here, you know what happens? Just watch. It puts it on the entire thingy. That's not what I want. Cancel that. Okay. So let's select this entire edge, and it goes all the way down here. In the event that you made a hole here, which you can, by the way, then it just picks up this, just picks this, because there's nothing going. Here we are assuming that we put the cylinder on top of that face and glued it together. Why did they make a hole? Okay. Now, user defined, this is in the plane YZ. Right there, YZ. It does not move in X, and once you know that, the rest of the story is exactly the opposite. And let's do the other side. So, user defined, this edge lies in the plane XZ, no Y. And rotations are exactly the opposite. You make any mistake in these things that I did on either side, the marks for restraints are gone. Even though everything else was right, one mistake in restraints in any of these, you lose the marks for all the restraints part. Okay. And I'm really sorry. There's nothing we can do at this point, because you have access to all your notes, you have access to all the videos, you have access to internet. Okay, so the least we can do is to say no part marks like this. Don't make mistakes like that. But I mean, move on. Okay, now what else do we have? Okay, so the whole thing is subjected to a temperature rise of 500 degrees Fahrenheit. Okay, so that is your load. Your load is right here, temperature field. Now notice that when I select this, it says, oh, the cylinder is raised by 500 degrees. Perfect. Actually, what degrees did I say here? Yeah, 500. Very good. Okay, fine. Now, that's no good. How do we know what we have to put? Temperature rise. Okay. Now let me just close this for a second. Let me just close this. Okay. So notice that as soon as I say temperature, it puts this line here, environment. And if you double click on it, it tells you what the room temperature is. So when you say temperature rise, it's going to be your 500 plus this. Or you can change this thing to 0 and use 500. That's entirely up to you. So I'm not going to do that. It's up to you, as I said. So I go back here to load, double click on it. This should be 568. Because there was 500 temperature rise, there was 68 room temperature. We say okay. Now, I have to also apply that temperature rise to this plate. So do it again. You do it again. If you can do that separately, you can do it at the same time. Let me double click on this. You can do it at the same time. If I select this, notice that, by the way, it put a big T here. That's for the cylinder. If I select this, it puts a T there too. So this is also in the oven. So the temperature will go up. As a matter of fact, these guys are also in the oven. Now, if I want to select this fellow, I can't do it like this. So what I could, I don't want to do it like that. Let's do another one. How about that? It works, but I don't want to, because this T is already there. I can see that. So let me do another one for this. Okay, fine. Both of them are here. You can see that. And I want to do it to this, okay? Because this rod is also sitting in the oven. So another one, because when you do it together, you can't see it. This guy, okay? This line. And if you have any issues with it, you can go and select it from the, where is that? Actually, if you had selected part body, you would have done the whole thing, the whole shebang. But it doesn't put any T here, okay? It doesn't put any T here, okay? It puts it there, and it puts it there. As a matter of fact, let me close this. Let me delete these two. Let's delete these two. Delete. And temperature rise. Put it on the part body. Part body does not put it on the surface. Take back what I said. Do it again. On this, there's a T. And by the look of it, you have to put it on that line too. And it doesn't put a T there. I can't see a T here. It's kind of hard to see. I don't think you can see it anyway. The whole thing is subject to a temperature rise. Now, run it and watch it fail. And you know why it fails. Can somebody tell me why does it fail? It did not run.
Connections?
Yes, absolutely. Absolutely. Let's try it. Oh, sure. Temperature applied several times. Oh, God. We made a really mess here. Let's do this. Let me delete this. I think it's this last one. It looks like it puts it on that beam. Because that's what it's complaining. So let me delete it.
The solid
Sorry?
selects the line as well, and vice versa. If you click the line, it selects the solid as well.
Okay, so let's, are you before the temperature you're talking about?
Yeah.
Okay, so temperature, this line? A line here or from
Just clicking it on the thing there.
this?
Yeah.
Or, see,
if you
that's what I did. That is what I did.
The body and the line.
Okay, so you're saying this should work. Is that what you're saying? Well, let's try it. Because that's what I did, I think.
No, you have one extra one.
What about that's, what?
Yeah, you only need 2 of them in the end. You have 3.
Yeah, I think for field 4, it selected the beam and the surface.
No, field 4 is good. Field 3 or field 1 or delete 3 or 6, and then you're fine.
Well, let's try. Let's delete this. Let's delete this. I deleted. So basically, all I have. This is the whole body. It looks like. No, but it doesn't take that cylinder. Oh, I see. See, this is the surface, and hopefully that line, and this is. Oh no, this is. This one is the cylinder and that line, and this one is the surface by the look of it, because it lights up. Let's try it. Okay, we told you your problem is, the problem is fixed, except that we know that this was not going to run because the connections are not defined. You can see that these guys don't see each other. They have no respect for each other. But that issue is resolved. Okay, so we fixed it. You work it out, no problem. I did it twice here. Good. Connections. So connection between the end of the line. So hide this. That vertex, make sure you select this guy. Now the corner of that surface, oops, the corner of that. So I'm going to hide that. And I can't pick this, so I'm going to hide this guy. This is terrible. I shouldn't put that white thing in there. And this has got to be what? What kind of a connection? What? Say it. Say it.
It should be a rigid one, right?
Rigid. Yes, rigid. Don't use fasten. Fasten does not work for ends. For vertex to vertex.
That would be my question here, Professor. Like,
yes.
When should we? I've seen the homework video, and I saw that when you connect a line to a surface that is rigid.
No, hang in there.
Is that a fact that I have to do that all the time, or what's?
No. Where did you see this? Where did you see this?
The homework video.
Which homework? The one that I assigned this year?
Yes.
I assigned you guys?
Mm-hmm.
And I made a line and a surface rigid, you're saying?
Yeah, but
Is that what?
it's like the same thing. It's literally what you did now. You're gonna put a rigid connection. It was the same kind of problem where there's a line and also a surface, a beam
Okay, all right.
structure and a
Okay,
surface
so
structure.
this is worth looking at it. Okay, so let's. Can I finish this thing? And then I want to go and look at what you're saying. Okay, let me finish this thing and then we go, because this I might have made a mistake, or I may have been a problem that was either stated differently or something else. Okay, but let's finish this thing and then we're going to look at that. Now, okay, we'll look at it. This is important. Okay, so we did this one. We did this one right here. This is the rigid one. And we need a connection between that cylinder and this. Okay? If we say the parts are perfectly glued or welded, this means the bottom of the cylinder is fastened to this. Okay? And that's really the intention of these problems. But if you took the cylinder and just placed it there and somehow kept it there, okay, the bottom may not be glued. The edge probably is glued, because if the edge is not glued, I mean, this is free to move in both directions. So you have two choices. You can make the bottom of this and that surface fasten. I have no problem with it. Some of you might say the bottom of this and that surface is contact, but this edge and the surface is glued. I have no problem with it either. Some of you might say that surface and this surface are fastened. I have no problem with it either. But what the intention was here was to make the bottom of this and that fastened, because I said all components are perfectly bonded, glued, welded. So I'm going to make a connection between this plane, and for the second component, I can hide this, or I can select that surface. It really doesn't matter in this problem, okay? Either way, all of these are going to get good marks, okay? Full marks. Because okay, let me do this. The bottom of this and that surface fastened. Let me delete this. Let me delete this. Let me delete this. Although I can fix it, let's double click on it. Instead of that surface, second component, instead of that, I'm going to say, hey, hide this. Ah, did I pick the right face? Cancel. I don't think I picked the right face. This is terrible. Get rid of this. Okay. Connection between the bottom of that, this face, and the bottom of this guy. Ah, okay, that's what I wanted to do. And this is going to be fastened. Because to be fair, I said all components are perfectly bonded together or welded together. That means this face and this surface must be fastened together. Where's that guy? Fastened. Is this here? Fastened. Okay, and that's last connection that I created. Here's the fastener sign. Okay, I'm going to run it, and then we go and look at your question. Okay, because this is going to be done once I run it, and I'm pretty sure this is going to run. You know, and you might ask yourself, well, how do I know what is what? Well, I told you, when you do these things for a living, they expect you to deliver something. You better go and find out how these pieces are put together. You can't just go ahead and just say, or if you do, then it's going to be a simple assumption that you're making, which may or may not be reasonable. Okay? Now remember, this is a temperature rise. Don't expect anything weird happening. Don't expect necessarily to go down by so much, or to the right or to the left, which can because of symmetry. This is, everything kind of grows. It's a uniform expansion, except that this beam is playing a role here. It says, hey, you can't uniformly grow. If this beam was not there, this would just uniformly grow or shrink when temperature changes. And then, of course, you know, you can look at displacements and things like that, and you know, very little stuff. So, are there any questions about this before we go to that question your friend asked? Should I look at your comments, or do you want to speak up? I'm not going to look at your comment. Speak up if you want. If you have a question, speak up, please. Now, let's go to this problem that you're talking about. So, homework, you're in section 53. So, homework 1. Did you say assignment 4? You said assignment 4?
5.
5. And you're in section 53, so it looks
Yes.
like, yeah, okay, so let's open this up. Now, is this the problem that I did for you guys?
That's the one.
Is this the one that you have to do?
Yes.
Okay. So what line did I take and said I rigid? When did I take a line and say it's rigidly attached to something else here?
I was talking about the connection type.
Yeah, I know. The only rigid
okay.
the only rigid that I should have done, and I'm pretty sure that's what I did, is this corner to corner.
That is exactly what I'm saying.
Well, that's good. That's what.
Yeah.
That's
but the thing is, like, I'm asking, is this a rule of thumb that when we have a beam and a surface is going to be a rigid connection, or that's only dependent on the case?
Okay, wait a minute. What connection did you create between what and what? Tell me between what
and the surface.
No, it's not. That's not. Yes, but when you pick that point, what did it say? When you pick that point, you remember what it said? It's at vertex.
Yes.
When you vertex to vertex must be rigid. Must be rigid.
God, I knew there's a rule of thumb out of this. Okay, thanks so much. That's what I need to hear.
Okay. Okay. All right. Anybody else want to speak up? You may have questions, but I'm asking you to speak up instead of writing it down. I don't want to, I don't like to go and read things. Are there any questions? Okay, because we still have 20 minutes and I want to repeat this problem. 15 minutes. We can do it in 15 minutes. We can do it. You want to do this problem as an assembly. Okay, so let's save this. Okay, so I'm going to kill this. I'm going to kill that. All right, it's a good practice. Product, not part. File save management. Save as. Desktop. New folder. Lab 53. Dash. Assembly, right? Assembly. On the test, we don't care how you do it. But I'm sure if you watch the videos, you'll notice that doing it with, and the stuff that I did, by the way, on Friday, you realize that it's easier to do it with part. Okay, so insert, new part, in there. We did the surface first. Let's do the surface now. Okay, so let me rename this thing. Properties, I'll call it surface. Surface. Good, let's make it. Double click on it. It'll throw you into part design, and I don't want to be in part design. I'll go to generative shape design, and I follow exactly what I did before. Like that. This was 4. This was 2. Okay. Exit. FILL. There we are. Insert the second part. Now, by the way, this second part is going to be my line. You can, if you want, put it in here, but I insist on putting a different part. Different part. Insert, new part. No. I'll call line. How about calling it bars? Properties, bars. Bar. Bar and bar. I told you that the reason I changed the name and the instance is because after the midterm, it's going to come and bite you if you don't do it right like this. So we create a line, point and direction. There is my point, and there is the direction, Y. and the length is 1. There we are. Done. Out. Insert. New part. This is going to be cylinder, right? Right click, properties, cylinder, sill, and sill. Sill and sill. Double click on it. Okay. Now I want to be in part design, so let's switch to part design. On the XY plane, I'll sketch my quarter of a circle, which was over here, right? Whoa. That's okay, we'll clean it. From there to there. And another one. From here to here. Let's give this thing a dimension. I think this was 1 inch. Yep. Exit. Pad it. I think it was height of 2 inches. Very good. Done. Everything is made out of steel. So metal, the steel on the product. You say okay. And as far as model is concerned, this is done. Now remember, on the test, if you're doing it like that, you have to give us the product, 3 parts, and the analysis. Don't forget. Now we're going to go to generative structure analysis. That thing is just like before. We have to do the rest. So we can do the beam first. There we are. There. Same size. We can do the 1D property on that. It was circular, and the radius was 0.02. Remember, we worked this out. And yeah, right there. You see this? Okay, very good. Let's mesh the shell, the plate. I changed this thing to be a little bit smaller. Okay. 2D property on that. That was the correct thickness, 0.1, because it's using the same numbers that we used a few minutes ago. Okay, very good. What do we do? Connections. Let me hide. Quick, let's do connections. Let me hide that and hide the sketch. We don't want to pick the sketch. This point. And for the second component, now we're going to bring that thing into the show mode. You can do it here too, but I'm going to hide. I have to hide that line and point and things like that. Hide. It won't let me take that, so I don't know, hide it. There. Okay. Vertex to vertex. Must be rigid. You can't have it fastened. If you try it, it'll give you an error message. Where's the rigid guy? This is rigid. Now we do it between this and this the way we did it before. So this face, if you're saying these are perfectly glued together, oh, okay, we'll pick it from here. It means that the bottom of this is perfectly glued to the top of that plate. Although that's not what we're doing, a little bit of difference because of the thickness of the, we talked about this a minute ago. Okay, good. And this is going to be fastened, okay? Where is the fasten guy? There we are. Okay, let's put our restraints here. Where's that beam guy? Right there. Hide and show. Okay, this end is clamped. Okay, these are surface sliders. Surface slider here and there. Now the symmetry of the shell. Speak up, speak up, speak up. not this.
Hide the line? Sketch?
No, it's this. It's that side.
Oh.
This is the symmetry of the shell. Not this side. This side is free, right? This side, okay? And this thing that I picked lies in the YZ plane, so it does not move in X. Rotations are opposite. It's so easy to get carried away, pick the wrong ends. And you don't want to do that because that will make you lose a lot of marks, unfortunately, for restraint. Everything may be okay, but you pick the wrong side, then of course we don't know whether you knew what you were doing or not. So Y direction, no displacement in Y, rotations opposite. Okay, so let's see now, temperature. So, okay, let's see. You guys said take this. Is that what you said? Let's take it. Okay, that's the temperature of that fellow, and another one for the surface. Now this, I'm not convinced that it's actually taking that temperature of this into effect. Let's see.
Professor, in assembly mode, it doesn't select the line automatically. You gotta click it.
Okay, so so let's see now. Where is the sky temperature again? That line from here, right? Yeah, that's what you're saying. Huh? Okay, good. Let's save this thing. Do not forget to save, because if you run and it runs into trouble and you have to kill the job, everything that you have done, except for the product and the part, is all lost because you didn't save. Okay, so let's run it. By the way, the temperature I didn't change. It was 500 plus 68, and it was exactly what we had before. Done. Okay, let's, I think the scale is okay. Yeah. So it gets fatter because it's growing, temperature change, temperature rise. It pushes on this beam. That's why the beam bends. You see that? Very good.